Welcome to episode number 2 of iPhone Development with Ben Sherman. In this episode, Ben starts cranking out a to-do list application and show you some Objective-C along the way, as well as ease you into what it takes to start building out an iPhone application. Now keep in mind as you watch this, we will be having an Objective-C episode coming up next. Right now, sit back, watch as Ben cranks it out.
So I'm going to launch Xcode, and we get this new project dialog. I'm going to pick this view-based application, and we're going to call this TechPub To Do. So Xcode gives me this window we've seen before. If we run it, now Interface Builder is a little cramped in this small screen, but we'll make do. So the first thing I want to do is drag a nav bar up to the top. So I'm going to go over here to navigation bar. You can see that it says UI navigation bar below it. That's the class that is going to be created. We're going to drag this up here. Notice how it snaps together, and we'll give it a title, TechPub To Do. And you can give it a tint color and give it a nice dark green. Tint color, and we'll give it a nice dark green. Now for our view, we're going to drag a UI table view. So if we scroll up in here to this class here, we see a table view. The class is UI table view. We're going to drag that over here, and it'll fit right in there. Now notice it snapped all the way to the edges. So I'm going to save this. We need one other thing, which is a button up in the upper right hand corner. So let's go find that button. Those are called bar button items, and we can drag it. You can put it on the left or the right. We're going to put this one on the right. We're going to call it, make it a bordered button. We'll call it add, which will give us this nice plus icon. You can add your own icons, but there's a ton of built-in ones here, like compose if you're going to write something, or trash if you're going to throw something away. In our case, add works well. So let's save that. Okay, to start off, what I want to do is show you how we could just display a few rows of data in our table view. And to do that, we're going to drop back into Xcode. So I'm going to use a shortcut key to get rid of these other two panes. Shift, Option, Command, E. So that's one you'll have to remember. Shift, Option, Command, E. And you can toggle back and forth to give yourself some more room. So we're looking at our TechPub To Do View Controller.h. And what we need to do is declare a couple of things in here. The first is going to be a container to hold the different to-do items. So let's go ahead and create that. I'm going to create an NS mutable array. And I want to create an NS mutable array because we'll be adding to it at runtime. If we just create an NS array, then the contents are going to be static and you won't be able to add new items to it. In addition, we're going to have our view controller handle the methods that the table view needs. And in order to do that, we're going to implement the protocols. Now there's two different protocols. The first one is UI table view delegate, and the second is UI table view data source. Now the data source handles methods like providing the table view with data. You'll tell the table view how many sections to display, what the rows are for each sections, and construct the cells. The delegate has methods for responding to events on the view, like for example when the user taps on a row. Now almost all of the methods in here are going to be optional, but there's going to be a few that you're going to have to look up so you know what to implement. So if we were to build this, we'll get a few warnings. We'll get 4 warnings for those methods that we haven't implemented. So we're dropped down into our .m file, and now we're going to start implementing some stuff. Now I'd like to keep things nice and tidy, so I'm going to create a couple of pragma mark dash and pragma mark initialization. And what that's going to do, we'll see in just a second. After some of the loading stuff, I'm going to create another pragma mark dash, and this one I'm going to put table view data source methods. Now if we go up to here to this little pull down menu, we can see that we have a section here for initialization and a section here for table view data source methods. So this is a good way if we have a lot of methods in the class to quickly navigate around. I'm going to create a couple of more because we're going to want to group these methods together. So we'll create one for table view delegate methods, and finally we'll create one for cleanup. So you can see that a couple of methods have been implemented but commented out, like this one to support auto rotation. For now we're not going to worry about that, so I'm going to delete that. We can see another one for did receive memory warning, so this is an area where we can clean up our data. View did unload is called when the view controller is about to be destroyed, and finally dealloc. Up in our initialization, they've created a constructor that we can use. They've also implemented a load view method, and this is if we were not using a nib file to build up our user interface. We would instead implement this load view method to programmatically build a user interface. But we're not going to use that, so I'm going to delete this. And finally, there's a view did load method, which is called immediately after your nib file has been loaded. So if you need to interact with elements on the view, like setting a button's label text or interacting with any other UI element, you'll do that in view did load rather than the constructor, because you want to make sure that those view elements have already been added. So we'll uncomment that because we'll be using that. Now this constructor actually isn't going to be called, and this is a bit of a hard point to explain, but basically the framework is going to call a specific constructor. And since Interface Builder is going to be the one building this for us, because we chose this template, it's going to call a different constructor. And so we want to implement the constructor that the framework is going to call so that we can provide our own initialization. Now, as it happens, if we were to implement the one that was commented out there, that's not the one that's called, and so our code would never run. So we're going to create a constructor here. A constructor is an instance method, so it has the dash. It returns ID, which is an alias for a pointer to NS object, so any object. And we're going to use init with coder. And this is basically like deserializing a class based on some decoded string or decoded some representation of the class. In this case, it's going to be the representation that was serialized into the nib file. And we're just going to pass this call off to our superclass. Init with coder, pass in a decoder. And this is a common pattern that you'll see. You'll say if self equals super, and you'll call the constructor on the superclass. And this is where we'll create our initialization code. And at the end, we'll return self. The reason why you want to have this if statement is you don't want to write your initialization code if your parent class failed to initialize. So what we want to do here is initialize that mutable array that we created earlier in our header file. We're going to instantiate it here and add a few items to it. So let's do that now. We're going to say items equals alloc init. So again, this is a pattern that you'll see a lot of times where you'll create alloc init in the same line. So now we have a mutable array that we can work with, and the retain count is going to be 1. So at some point we're going to need to release this. So let's go ahead and do that now. Go down into the dealloc method. Before the super dealloc call, we're going to call items release. Now we don't call items dealloc because somebody else might actually be holding on to this. We just let the framework know that we are done with it. Now you may be wondering why we've placed the @ symbol before the string. That's because in C languages, just putting quotes around it creates a C string, which is just a character array. And character arrays can go on forever, and so they generally have a nil terminating character to determine when the string stops. And that causes all kinds of headaches, like all your string copy functions have to take into account whether or not a string is nil terminated or not, and they're generally not easy to work with. So in Objective-C, we work with NS-string instances, and this is our way of telling the compiler that this is how we create an NS-string instance. And we're going to add 3 of those to our array. So let's build. We should still get our 4 warnings because we haven't implemented those table view methods yet, but let's do that now. So inside the table view data source methods, we're going to grab the appropriate UI table view delegate and data source protocol methods to implement here. And one way to do that is by searching for UI table view delegate. Now there's some pretty excellent documentation on Apple's site. So we can scroll down and see all of the different methods that we can implement. Now this is on the delegate. We actually want the data source. Okay, so here are our 2 required methods. The first one is cell for row at index path. We'll do that one in a second. We also have number of sections in table view. In our case, we're just going to have 1, and 1 is the default, so we don't have to implement that. But we do have to implement this one, table view, number of rows in section. So let's copy this. We're going to go back over to our code, and we're going to paste it right here. So this is the function, and eventually you'll get to know these by heart. So we need to return the number of rows here, which is really the count of items that are in our array. So let's return items count here. This is telling the table view will call this method on its data source, and in this case it'll be us, and we're going to return 3 because that's the number of items in our array. So the table view is then going to say, okay, give me the cell for row 1, now give me the cell for row 2. So that's the very next one we have to implement. Let's go back over to Firefox to the Dev Center, and we're going to grab this one and paste it right there. Okay, so we're going to write some really simple code here that we'll clean up in a bit. But basically we need to create a table view cell. We'll use that same pattern, but this time we're going to use a special constructor. We're going to call init with style. So when you're creating table view cells, you're going to call init with style because there's multiple styles that a table cell can be in. And if we prefix our code with UI table view cell style and hit escape to bring up this window, we can see the different ones here. We're going to use the default style. To hop over to the next placeholder, which we can see over here, you're going to hit Control/. And you can't see that. Let's hit a line break here. Control/ to highlight that, and we need to give it a reuse identifier, which I haven't explained yet, but I will. Okay, so now we need to set the cell's text label .text property, and we're going to set that to the object.index and what row we're looking at. So notice how it says cell for row at index path. Now index path is a data container that contains the section that we're in and the row we're in. Now since we're all in the same section, all I care about is what row we're in. If you're curious about what sections are, that's like if you're looking at the phone book, we have a section for A and a section for B, so that all of them are grouped together logically. But in this case, all I care about is the row. So I'm going to call indexPath.row, and that's going to give me either 1, 2, or 3, or 0, 1, or 2, since it's 0 based, and that's going to be the same. That's going to be the same index to our array. So if we've pulled out the text of the item, now we need to return the cell. Now we hit build, and we're succeeded. Now table view delegate methods aren't required, so we'll implement those when we're ready, and then the code will just respond. The application will just respond accordingly. So if we run this, we'll see our user interface, but nothing's actually going to happen. So we see the user interface that we've set up, but it's not actually rendering our stuff. Why is that? And that's because the table view itself has a delegate and a data source property, but we've never set that. And the way we do that is in Interface Builder. So I'm going to pop Interface Builder open again. We're going to look in our main window here, and we've got our view hierarchy. So we've got our view underneath our table view and a navigation bar. And we've got Files Owner, which, if you recall from the last episode, is the type of file that this manages. In this case, TechPub to-do view controller. And that was the view controller we were just writing code in. So what we need to do is we need to set up an outlet from the data source and the delegate for this table view over to our view controller. And that's going to make those connections. So if you recall from last time, we're going to hit Control and we're going to drag over to here, let go, and we're going to assign it to one of these delegates or one of these outlets. So we'll do data source and we'll do delegate. Now that is a little confusing, so just let that sink in a little bit. When we ran the application, since those things were not set, the table view had no delegate or data source, so it didn't ever call those methods. Now, since we've made these connections, the table view knows I'm going to ask this class for all my information. I'm going to ask it for how many sections I have, how many rows in each section, and for each one of those rows I'm going to ask it for a cell. And then when somebody taps on the row, I'm going to ask my data source, I'm going to ask my delegate for what to do when somebody taps on a row. Now we haven't implemented that method yet, so it actually won't do anything, but we have made the connections. So the next step for the delegate is to implement the methods that we want to respond to. So I'm going to hit save, and we're going to go back into Xcode and run it. And this time it loads up our items, and we have item 1, 2, 3, and we can scroll. And since we're on the iPhone SDK, we actually get this really nice scrolling behavior. You have the nice animation. You can click and something highlights. So what we want to do next is when they select this, it actually doesn't stay selected. We want to deselect it immediately and add a little check mark on the end. Now to do that, we need the notion of more than just a string. So instead of using a string, let's use an object that we define called to-do. So I'm going to do that right now. I'm going to right click on classes, say add new file, pick Objective-C class, and hit next. I'm going to call this to-do.m and leave this check mark checked so it creates the header file for us, and we'll hit finish. So now we're looking at to-do.m and to-do.h. I'm going to collapse those for a second. So what does our to-do look like? Our to-do looks like, well, it has some text, has a boolean for whether it was completed or not, and it might have a date added or something else, but for now that's good. We probably want a custom constructor also, so I'll define a method header for that. Remember, all constructors return ID and start with the word init, so I'm going to call this init with text. And we also want to create properties for each of those so they can access the text property and the completed property. So let's do that. Now, if you don't recall what these mean, remember properties are a way of generating the getter and setter methods. And so these items, these tokens inside of the parentheses are going to tell the compiler how to generate those. Now, non-atomic means that we don't care about multi-threading, so don't worry about putting a lock around the getter and setter. And in this case, since we're using a string, the general practice around using strings with properties is you want to copy the value rather than retain it. Now, if you retain the value, you're now pointing to the same exact memory location that other people might be pointing to, and so changes in one side would affect the other. And with strings, sometimes that's not what you expect. So generally I put copy here. For the Boolean, we don't need to do anything like that at all because it's not a reference type. It's not a pointer to anything, it's just a value on the stack. Okay, so I'm going to hit save. I'm going to just copy this real quick. Now we're going to flip over to our implementation file. A quick way to do that is to hit Option, Command, up arrow. I'm going to paste these in here and change this to synthesize. Now again, this stuff starts to become second nature after a while. It does take a little getting used to. But basically we need to synthesize the property names so that it knows to actually generate those. Let's implement this constructor. Now in this case, this is a custom constructor, which is why I defined it in the header. But the superclass doesn't actually have that, so we have to call some constructor. And every class has an init. So notice how we're using the dot syntax here. We could specifically assign it to our instance variable, but this is going to assign a pointer to something that somebody passed into us. So we would actually have to do something like text copy to copy the string and put it in our instance variable. But our property is already defined to do that. So if we use self.text, it'll actually copy it for us. So we're reusing logic there. Okay, so now we have a to-do class, and it looks complete enough. Let's go ahead and get out of here, and we'll go back to our view controller. Now, see how we're adding the string here? We actually want to add to-do items. So let's create a little helper method to do that. Now, if you don't want to expose this to the outside world, it's okay to create a little method above, somewhere above the method that you're calling it from, so that it's defined ahead of time. And this method can just be used in this class alone. You don't necessarily have to add it to the header file. So I'll create a void method called add to do. It's going to take the string and a string for the text. Now before we talk to the to do class, we actually have to import the header. So we're going to create our to do alloc init, and we're going to say init with text. So there's our friendly constructor in use there. Then we're going to add it to our items array, and then we're done with it at this point, so we're going to release it. Now this may take some getting used to, but I say we're done with it. In this case, the array is now hanging on to it. So the array's implementation, it actually retains the objects that you add to it. So when we call init with text, the retain count goes to 1. When you add it to the array, the retain count goes to 2. And now we've released it because we're not going to interact with it directly anymore. The retain count goes to 1. So it's not deallocated yet until we clean it out from this array. Okay, so now we're going to call, after we've initialized our array to a new mutable array, we're going to call self add to do, and we'll say take out the trash, self add to do the dishes, record a screencast. Okay, so we have a little helper method that creates the to-dos, sets the text, adds it to the array, and releases it. So now we have to change our table view cell text because we're expecting this to be a string. So instead, let's pull this out into a to-do. And we'll call to-do.text. Now here we're using dot syntax, which is going to call the getter of our text property. So let's save and build. See, we have a warning here. It's complaining that our constructor here is using the same name of an instance variable. And that's usually not a good idea. So let's call this some text. Okay, and we build and succeed. So now when we run it, we should see the new items, and it should still function as it did before. Okay, so now that we have a to-do, and it has a boolean for whether or not it was completed or not, when we select the row, we can toggle that value. So let's drop back over here, and we're going to go back to, and we go to the managing selections, and there's one method here, table view did select row at index path. Now there's a lot of them here, so you kind of have to take a look and see what's available. But the most common one is did select row at index path. So we're going to go inside of our pragma section here and paste in that header. In fact, if we grab the more friendly one, we'll paste in that header. Okay, so I mentioned that I want to deselect the cell immediately. So I'm going to call table view deselect row at index path, pass in the same index path that I was given, and I can say animated yes. This actually isn't going to matter in the end when we finish, but we can see what happens if we say animated yes versus no. So we run it again, and this time you can see that it deselects it immediately. Now notice we get this nice fading animation. That's one of the benefits you get by saying animated yes. Now when we start adding the toggling the check mark, we actually have to reload the data on the cell, so it's actually going to kill our animation. But in most cases, saying animated yes doesn't hurt. So what we want to do here is if our cell is completed, then we want to add an accessory to the cell. So there's a property called accessory type, and you have to prefix it with UI table view cell accessory, hit escape, and these are the different things that you can put on the end. Now check mark, it's obvious. A detailed disclosure button is like, if you're familiar with the favorites on your contact list, you tap the row and it'll actually call the predefined number for that person. But if you tap the detail disclosure button, which looks like a little circle with an arrow in it, that'll actually take you to the contact. Now in most drill down applications like Pocket Tabs, my application, you start out with one row, which is an artist, and you tap the artist and it'll take you to more data relating to that row. And so that's a perfect case for a detail disclosure indicator. The indicator is just the arrow, and it doesn't have a button look and feel. So let's go ahead and use the check mark. But we only want to use that if the to-do is completed. Okay. And when they select the row, we're going to grab the to-do, which I'll grab from here. And we're going to say to-do.completed equals not to-do.completed. So that'll allow us to toggle it back and forth. So now let's run it. And we'll notice that it's not actually adding our detailed disclosure indicator, even though we told it to. The thing I forgot to do is reload the data. We have to tell it to re-render those cells. So we can do that by calling a method on the table view, reload data. Now this is the line I was telling you about that would kill the animation of the selection, but which is fine. Okay, now we have our excellent toggling of check marks. So what's left is there's some cleanup on the cell code that I want to show you. And then there's the adding of new items. So one of the things that you have to be aware of is the iPhone is very resource constrained. And so as you're adding lots and lots of objects, the table view itself is designed to handle thousands and thousands of rows. And it can do that actually pretty nicely if you play by the rules. Now one of the bad things about a table with thousands of rows is that means we have thousands and thousands of these little cells, and all of them are almost identical except for something like the text on top of it. So we don't necessarily need to create a new cell every single time, especially since there's only 10 to 12 visible depending on the height of the cell. So what they have is a reuse identifier and a reuse queue. So when a cell goes off of the view, meaning it's being scrolled off, they'll actually reuse that object and use that to render the next visible cell, the next cell that's about to be visible. So as you're scrolling, it's reusing these cells. And in order for us to take advantage of that, we have to first test to see if there is a cell we can reuse. So we're going to create a common identifier. Now you would have to have one of these for each different type of cell, but since all of our cells are basically the same, we have one cell identifier. And I want to test to see if there's a table view cell in a reuse queue. So we're going to call on the table view DQ reusable cell with identifier cell identifier. If cell is nil, then we can create it. We'll use the variable here, cell identifier. Okay, so once we've either created it or retrieved it from the queue, now we can set the text label and the accessory type. So, and those are the things that differ between the rows. But if you had a custom height or custom graphics for the cell, then you would all put that inside of this if block. It would only be created the first time that cell is created. And this is a common pattern that you'll use. Now there is one problem that we have in that in this case where we're doing alloc init, the retain count is 1 and then we hand it off to somebody else and we never actually dealloc it. So we could call release right here, but then it would be released before anybody had a chance to use it. So that's not a good idea. The other problem is sometimes we dequeue it from the table views reuse queue. So the retain count has already been dealt with, so we don't want to over release it in that case. So what we need to do is somehow tell it to release, but only if we hit this branch and only after the person who receives it is able to call retain on it. And the way they do that is through a mechanism called auto release. Now if I were to wrap this in one more call and call auto release, this puts it in an auto release pool, and every clock cycle the pool is cleaned out and they call release on every object in the pool. So this is perfect for these factory type methods where you're creating something and returning it for somebody else, and then after that you don't care. The only problem with auto release, it seems like magic and it is very, very handy, but the problem with auto release is that when used too often it can hide issues. For example, if you call auto release on an object that doesn't need to be released, that means you're going to release one too many times. If you were to just call release too many times, your app would crash the moment you call release. But since auto release is placing it in a pool and sometime later it will be released, that can cause problems further down the line in an area where it doesn't crash on that line of code. It crashes some undefined time after that. So it can cause some pretty hard to track down bugs. So I would say only use auto release when you absolutely have to. And in this case we do. Now one thing we have to do now is if the to-do is not completed, then we need to clear the accessory type. Since we're reusing cells now, the accessory type will be retained across cell uses. And so we might actually get a cell that does have the check mark and we need to clear it. So in this case, we need to call UI table view cell accessory none. And now our application works again. Now we have one thing left to add, and that's the adding of new items. I think that'll be better saved to a further screencast. So take the time to go back and look at what we've learned. We've learned how to create a user interface using Interface Builder. We added items to a nib. We added a tint color to our navigation bar and a button over here and a table view to the body. We set the data source and the delegate outlets from the table view to our view controller. And we did this in Interface Builder using the control, click, and drag technique. Then in our view controller, we implemented the appropriate methods: number of rows in section, cell for row index path, and did select row at index path. And we did that in order to create our to-do items that are coming from an NS mutable array. We output the text. We used the reuse queue for our cells so that we can get good table view scrolling performance. And we're adding the checkmark indicator, or the checkmark accessory type, to each row. So next time, we'll take a look at some more advanced things we can do, and we'll start off by adding new to-do items. Until then, see ya.